and welcome to lesson 3 of data analysis fundamentals, brought to you by Earth Creations. In lesson 2, we saw how to code our data in a spreadsheet, import it into SPSS, then write the codes and adjust the variables. Make sure that ordinal categorical variables take the measure of ordinal. So in lesson 3, we will continue with data cleaning. Where we'll define data cleaning, then we'll talk about missing values, and then we'll talk about system and user missing values, how to check for missing values, specifically system missing values, and how to deal with missing values. So data cleaning is just a way to make sure that your data is not messy. Just a way to make your data ready for analysis, dealing with things that are not necessary, and adjusting the data to make sure it is fit for analysis. So what are missing values? Missing values are known data or empty cells in a data set. Yes. Missing values could also be values that the user, like you and I, the user has instructed the software to ignore. Typically, those ones will be user missing values. So, where do missing values come from? Some respondents weren't asked some questions due to the questionnaire routing. A respondent skipped some questions. Something went wrong while entering, converting, or editing the data. Some values weren't recorded. These are some of the ways in which missing values brought about. System and user missing values. System missing values are values that are completely absent from the data. In SPSS, system missing values are shown as dots or periods. In this example, you might not see clearly. Let me show you in SPSS. We said system missing values are shown as dots or periods in SPSS. This is one of them. As you can see, this is a system missing value. This is another one here. This is another one here. Those are missing values. User missing values are values that are invisible while analyzing data, or values that the user has instructed the software, in this case, the statistical software package for social sciences, SPSS, to consider missing. In this way, SPSS ignores such data during analysis. So the values are there in your cells, but SPSS does not consider them as valid data entry points. In some cases, system missing values make perfect sense. Yes. For example, in a survey, respondents could be asked, "Do you have a car?" That's question 1. Then question 2, if yes, what color is your car? Well, if someone answered no for the first question, then should the person answer question 2? No. If you don't have a car, then you will skip the question on color car. Automatically, that becomes a missing value. That is an example of a typical user missing value. And as such, during data coding, the data analyst might assign a particular number to that question that the respondent skipped, and then the user will tell SPSS that treat this particular number as a missing value. Now, how do you check for system missing values? We have said system missing values appear as dots or periods in SPSS. How do you check? That is, you are now into data cleaning. How do you make sure that your data is not having missing values? The first thing is to check if there are missing values at all. How do you check for missing values? The very first thing you have to do is to recall your sample size. What is the sample size? And the second thing you do is that you run a descriptive test and you check whether all the frequencies in your descriptive test results match up to that your sample size. Let me show you in SPSS. Okay, this is our data. Data we started with in lesson 2. We have imported it into SPSS. Now, to check for missing values, what some users do is that they have to scroll down looking for dots, which is very, very is not the best way, because you can always skip. The human eye is liable to error. So what you do is, we remember that our sample size is 100, right? The best way to check it is just to scroll right down. Let's see that our sample size is 100. Last data values here at the serial number 100. So to check if there are any missing values, you have to do a descriptive test. So you come to analyze right up here. Where my cursor is, click on analyze. Come down to descriptive statistics. Come up to the right. From frequencies, you move down to descriptives. Click on descriptives. Then click inside. Take Control A. Control A will highlight all your variables. Then you use this arrow and transfer them this other column where you have variables. Since we want to do just frequency tables, we don't bother about options for now. We want to do just descriptive, we will not bother about options for now. So you will just click on OK. Then the output comes and you look at this very first, this second column where you have N. These are the frequencies. This serial number is not even of our concern for now. We could even allow it. During data wrangling, we might even have to delete this serial number because it will not really have anything to do with us, not doing any input to our data. So each range has 98. Normally, each range is supposed to be 100. If it's having just 98, it means that there are 2 missing values. So level of education 100, no missing values. Marital status 99, we have 1 missing value. Satisfactory rate 100, no missing value. Systolic blood pressure and diastolic blood pressure, they all have 100 data entries. So these ones have no missing values. Distance has 1 missing value. Time has 1 missing value. So you see that anyone that does not measure up to a sample size will mean that there are missing values. So you go and look for those data points and arrange them. Okay, let us continue. Now, how do you deal with system missing values? We have checked and we have seen that some of our variables have missing values. How do you deal with them? The very first thing is that you can ask the respondent. This one is difficult. It was an online survey. You want to send them a mail. Do you not fill this question? Please, can you fill it? If you administered questionnaires and you have the respondent's contact, you might want to call and start talking, which is difficult. You might not be able to get to some respondent. So, but if you can, that's one of the ways to get those missing values back. Then you ask the data entry person who entered the data into the spreadsheet, because it must not always be an online form that has generated the data for you. You also have physical questionnaires from which you have entered the data, like what we were demonstrating in lesson 2. So in the course of entering the data, there might be a mistake, or the person might skip a cell. You just need to call the person and say, please, could you verify, or if you're the one who did it, you should verify if there was an error, you can adjust it. Another way to replace the missing value is to replace the value with the mode. That means you get the mode of the variable. We have said the mode is the value that occurs the highest number of times. So you assume that that value that was missed out would be, since there's a particular value that appears so many times, take that value and put there. So just assume. Then another way is to instruct the software to treat it as a user missing value. That means you can give it a particular value that was not in your code anyway. Then you tell SPSS that treat this as a missing value. Remember that in this case, the sample size will reduce. The sample size, if for example you have one missing value and you tell the software to treat it as a user missing value, sample size will reduce from 100 in this our case to 99. But the percentage will still give you something valid. Yes. So this is our data set, and from the descriptive statistics that we ran, we saw that each range had two missing values output. So that each range had two missing values, and parameter status had one missing value, and distance had one missing value, and time had one missing value. And from our notes, we said that we can replace that missing value with the mode, or we tell the software to treat it as a user missing value. So how do you even know the mode before replacing it with the mode? You have to run frequency. You have to run a descriptive statistics where you have frequency tables. You go to analyze, choose descriptive statistics, you come to frequencies. Then you can choose those particular variables which had missing values. In this case, age range has a missing value, two missing values. Marital status has one missing value. Time has distance has a missing value. Time has a missing value. And you make sure that display frequency tables here is checked. I'm not really come here since we are just doing data cleaning. You don't bother about this for now. You click on OK. Then you have some result. So age range, what is the mode? You simply have to look at the highest value here. Highest value here is 25, right? And 25 is the age range 28 to 32. So the age range 28 to 32 appears the highest number of times in your data set. And so, which code did we give for the age range 28 to 32? We can come back to our data. Then we go to variable view, come to age range. Look at it. The age range 28 to 32, we gave the code 3. So we can come back to data view. We look for that missing value and place it in the number 3. So we are here. Then we are looking for, there are two missing values. We are looking for two empty cells to replace them with 3. This is the very first one here. So replace it with 3. Click here to highlight. Move down if you have any other one. So we are done here. Replace it with the mode. Then we come back to our results, our output. We look at marital status. We say marital status had one missing value, right? For example, if you look at the total here, you see that the total is 99 instead of 100. The missing system 1. So what is the mode here? The mode is those who were married are most represented 45. So the mode is 45. And recall that when we were coding, we gave the code 2 to marry. So we'll go back to our data and then go to the marital status. Okay, we get the missing value and replace it with 2. In this case, we're replacing with the mode. So this is how you can deal with missing value. Another way is to treat the missing value as system missing value. But I want to say that I will treat that only when it is necessary. So let me show you how. Okay, this is a typical example where we have user missing value. In this questionnaire, the participant was asked, have you ever been diagnosed of Helicobacter pylori infection? Helicobacter pylori is a bacterium that causes gastritis. So the next question is, if yes, are you on treatment? So in this case, from the variable view, you'll see that those who have been diagnosed, if you have never been diagnosed, no, no took the code 0. And those who have been diagnosed said yes, and that was the code 1. Okay, if we go back to data view, we'll see that we have 0 and 1s here. Oh, have you been diagnosed? No. Have you been diagnosed? Yes. Then, if yes, if you have been diagnosed, or if you are diagnosed of it, are you on treatment? In this case, 0 takes the code for no, and 1 takes the code for yes. And then if you look carefully, you'll see that those who have never been diagnosed in this column, they're taking the code 2 here. Hope you can see that. This 0 stands for those who have not been diagnosed. Then the second column here, or the next column says, if yes, are you on treatment? They take the code 2. Normally, this is supposed to be a missing value, right? Because these people are not supposed to answer this question. Very good. So all these codes that we gave here, 2, we will treat them as system or user missing values. How do you treat as user missing value? You come to variable view, you look for that particular variable. If have you been diagnosed? Yes. If yes, are you on treatment? We say, okay, 0 is for somebody who is not on treatment. That's no. And yes is for those who are on treatment. Then for those who did not answer that question, look, this is missing, the column for missing. We come there, we click on it, and then you choose discrete missing value, you put that 2, and click on OK. So we have instructed the software to treat this as what? A user missing value. So during analysis, SPSS will ignore these 2. For example, if you have to run a frequency table for that particular one, yes, are you on treatment? This will be it. And then you have the result here. You will notice that the total is 31 and the ones that are missing are 69. But then when we are going to choose, if we have to copy these values, if we have to copy anything from here to our table, which will present to our or if we present in our data or in our results, we're going to copy this valid percent. We're going to copy these 2. Why? Because this is the one that has treated just the 31. In this case, the 69 missing ones have been ignored. So this is the valid percent I'm going to use. Okay. What is data wrangling? Data wrangling, sometimes referred to as data monging, is the process of transforming and mapping data from one raw data form into another format that is more useful for analysis. Data wrangling allows analysts to analyze more complex data more quickly. Steps in data wrangling. We have discovery, structuring, cleaning, enriching, validation, and publishing. Discovery. The first step of data wrangling is to gain a better understanding of the data. So in discovering, you are trying to understand your data detailedly. Different data is worked out and organized in different ways. Structuring. The next step is to organize the data. Raw data is typically unorganized, and much of it may not be useful for the end product. This step is important for easier computation and analysis in the later steps. Cleaning, where you might say we are doing data cleaning, and inside data cleaning, we are talking about data wrangling. Then while talking about data wrangling, we're talking about cleaning. There are many different forms of cleaning data. For example, one form of cleaning data is to catch dates formatted in a different way, and another form is removing outliers that will skew your results and formatting null values. This step is important in assuring the overall quality of the data. Just to mention that data wrangling is a broad topic in data science because it's a fundamental course, so we are just skimming on data wrangling. In enriching, we determine whether or not additional data would benefit the data set that could be easily added. For example, you might, of course, are going to see that in your data set at the end, you might want to have speed. And then you look at your data and you realize that, okay, speed is meters per second. So you need to have distance and you need to have time. That distance has to be measured in meters and time has to be measured in seconds. So you realize that the distance in your data set was measured in kilometers. So you have to convert all those values to meters. So you may want to create a different column of distance in meters. That is enriching your data. You want to enrich it, you want to bring in an additional data that will benefit the data set and that it will make it easily analyzed. Validating. This step is similar to structuring and cleaning, yes. So you use repetitive sequences of validation rules to assure data consistency as well as quality and security. An example of a validation rule is confirming the accuracy of fields through cross-checking their data. Publishing. Prepare the data set for use downstream, which could include use for users or software. Be sure to document any steps and logic during wrangling. So you simply have to document, for example, if you have added new variables, you should be able to document all that. Okay, so in data wrangling, you simply want to make the data useful and get rid of stuff that are not necessary. For example, you recall that while we were coding in lesson 2, or if you have not watched lesson 2, I advise you to do that because these videos are consistent. You realize that we added this column in our Excel sheet in order to guide us in coding. But now SPSS already has serial numbers. So this column is no longer useful. So we may just want to highlight like this. We right click, we cut it off. Not necessary. And then we talked about data wrangling. Yes. Data wrangling, you could also be able to tell SPSS to use some values as user missing values. In as much as you can also change some variables. Like we just gave an example of distance in kilometers, assuming that in this data set we want to have speed. Let's say people run different distances and the times they took were recorded. And now we need to know the speed of each participant. Maybe from there we would like to get the average speed of a participant and all that. So you realize that at the end you need to have speed. The unit for speed, the standard unit for speed is meters per second. But you realize that in this our data set, distance, instead of distance being measured in meters, distance is measured in kilometers. So if you don't have an idea of data wrangling or how to convert, you might have to do it manually. Like to convert from kilometers to meters, we multiply by 1000, right? You might have to come here, you multiply all these values from 1 to 100 by 1000. That is really going to take you a whole lot of time, and that will be if you are not versed, or if you are not if you are not versed with SPSS, and if you're still a beginner. So in data wrangling, you might want to create another column where we'll tell SPSS to take this one, take all these values, multiply them by 1000. Then you give us the result. So this is how we will do it. Remember, you can do this for any variable. You just need to know what you want the SPSS to do for you. So we'll come right here to transform. Click on transform. You want to compute a variable. So we'll take compute variable. And then which variable do we want to compute? We want to compute a variable that has distance in meters. Remember, this is just sort of coding, programming. So you don't have, there's no space, you don't use space when you're typing variable names. So you rather use the underscore distance in meters. If you give space, especially will recognize it. The distance in meters, that is the name of the variable that you want to give. And what is the type and label? Click here, type and label. You want it to be scale. You write scale here. If you want it to be original, you write original. But in this case, distance in meters is scale, right? So if you don't know what a scale is, you need to watch our lessons 1 and 2 so that you follow through. It is numeric, it's not string, right? It's numeric and scale. So you take okay. So how will you get that new variable? You will take the variable which is distance in kilometers, click on it, transfer it to this numeric expression, transfer it here. What do you want to do with this particular variable, distance in meters? You want to multiply it by 1000. So you come and click here. This asterisk sign is the multiplication sign in SPSS and in most programming softwares like arrow. So you want to multiply this by 1000. So multiply by 1000. So yeah, creating a new variable called distance in meters, and that new variable is going to be created by taking all the values from distance in kilometers and multiplying them by 1000. So I think we click on OK. Then we go back to our data sets. Then come right here and we'll see that a new variable has been added, distance in meters. And the distance in meters is all, each value here has been multiplied by 1000. 1.5, if this 50.5 rather will give you 500. So this is data wrangling. You have actually converted this variable to a format, you have changed it to a format that is meaningful for your analysis. Okay, there's a lot about data wrangling that you will not be able to explore because this is a fundamental course. But there are always materials online for you to read and explore more on data wrangling. So in data wrangling, we talked of removing non-useful data, which we have demonstrated here. We talked of ignoring variables that are not connected. For example, the serial number does not have anything to do with us, so we ignore it. And then in this case again, we're going to always ignore distance in kilometers. Since we've already computed distance in meters, we need to ignore this one. And either we leave it and then we never use it, or we carry it off. So that our data, you look at it now, you see that it's getting smaller and will be easier to manage. And then we compute new variables. We have demonstrated it here, how we computed distance in meters from distance in kilometers. And then another way or another thing in data wrangling is to check for outliers. Yes, outliers are data points that are very far from each other. They could be very small data values or very large data values. These outliers can actually affect your results. For example, when you want to do regression and other things. So in data wrangling, you need to check if you have outliers in your data sets. So in this example, I'll demonstrate with one variable. And the outliers are mostly in the field. But recall that in categorical variable, you could also make a mistake. Instead of putting 2, let's say you're putting the put 1 and 2, Instead of putting the code 2, you put 22. In that case, 22 will be an outlier, and you might have to check that. So how do you check for outliers? Let me use this column for distance in meters to demonstrate. Okay, so to demonstrate, to check for outliers in your data set, come to analyze. In SPSS, you mostly be using analyze. Come down to descriptive statistics. Come to explore. Click on explore. You choose the variable whose outliers, or the variables in which you want to check outliers. In this case, you want to check for scale, for distance in meters, which is a scale. You take it to the dependent list. Watch closely, dependent list, and then you click on statistics here. Come and click on outliers to check outliers. Click continue, then click on OK. Then this is your result. You scroll right down to this box plot. We call this a box plot. If you don't see anything star or circle, know that there are no outliers in your data set. But if you see something, there are outliers. So in this case, we have two outliers, 71 and 95. We have these two outliers. Okay, now we have outliers. The second thing is, can these outliers affect your result? How will you know if these outliers can affect your result? You scroll up to descriptive statistics here, and then you look at the mean. This is the mean, 1570, and you compare this mean with the 5% trimmed mean. The 5% trim mean is 948. So 1570 and 948, there's a huge difference between the two, right? There's a huge difference between the two. It means that these outliers that we have here, they're going to affect your result. And this is a scale. So if you have to run regression analysis, the results you're going to have might not really make sense. So you have to deal with these outliers. How do you deal with outliers? It's similar in a way we will deal with missing values. You can either tell your SPSS to treat them as system missing values, as user missing values, sorry, or replace them with the mode. So I'd always like to replace with the mode. It's easier. So how do I get the mode for distance in meters? I'll simply run a descriptive test and get the frequencies. So distance in meters, get the frequency, and we get the mode, which one appears the highest number of times. We have 34 here and it's 1000. So 1000 appears the highest number of times. Okay, it means that I can go to my data sets and replace 71 and 95 with 1000. 5 and 71 and 95. So I can come here, it's already highlighted. To find 95, I can just click Control F, looking for 95, step 95, and I click on enter. Search 95. Okay, it wants to search me for a string. Okay, these 71 and 95 are not the values in your data per se. There are case numbers. So 71, the case number 71 takes the value 55,000. So you are looking for 55,000 in your data set. And 95 takes the value 9,000. So we are looking for 55,000 and 9,000 in our data set to replace with 1,000. So we will come to our data sets here, take Control F, and we find 5,000. Let's find 55,000. The first thing to do is that you can just find 55,000. When you click on it, it's automatically highlighted. This is 55,000. You can replace it with 1,000. We have a missing value here, so you can as well replace it with the mode. 1000. Then we can go back to our output and we see that the other one is 9000. So the other way to do it is to find and replace. Just click here, click Ctrl F, click replace. We are looking for 9000. I want to replace it with 1000. So find it, SPSS will find it and replace it for you. So you just click replace all. And then SPSS says one replacement was done. So you're done. If you want, you can check on it again. You're coming to analyze, descriptive, explore, this case there. Click on OK. You come right here. You see that you don't have any outliers again. This the box plot does not have any outliers compared to this one here. So that is data wrangling. And to round up with this, talk about data exploration, which is an approach similar to initial data analysis, whereby data analysts use visual exploration to understand what is in a data set as well as the characteristics of the data. These characteristics can include size or amount of data, completeness or correctness of data. Data exploration can be done in SPSS by running a descriptive analysis and or frequency tables. So normally, data exploration is supposed to come even before data cleaning and data wrangling, so that you know what you can do some frequency tables. You see what is wrong with your data. You try to arrange it. So, but I always choose to first of all check for my missing values, do some data wrangling before I come to data exploration, such that if there are any problems, the problems will not be as many as they could be if I do not start with data cleaning or data wrangling. So for data exploration, it is simple. You just have to do some, as the name goes, exploration, and do some frequency tables, analyze descriptive statistics, frequencies, can get everything, frequency tables, just to know data sets like sex. In sex, you see that we have some issues, right? We're supposed to have F and M, but we have D and F, M, MF. Some mistakes in data entry. So data exploration, you are checking for this. Okay. So there are some two mistakes here. You need to go back to your data set and replace this D probably with the mode. And if you look here, you see that the mode is F because it has the highest frequency. So you might have to go and replace D with F and replace MF with that. So in data exploration, you're just checking, okay, the data has this level of education, you're having a 4 here, you're having 22. So you need to go and check it out and replace it. That's data exploration before you come out with an analysis. And then there's the missing value from data status. Yes, it's one missing value. You have to check that out. So in data exploration, you can run frequency tables as well as you can run descriptive. And you get a summary of everything here. Basically, that is it. So I believe if you have a data set now, you should be able to describe it. Then you should be able to code, do some import into SPSS, and do some cleaning and wrangling. Yes, so in the next lesson, that'll be lesson 4, we'll dive into analysis. We'll talk about parametric tests, non-parametric tests, when should you use them, and what type of variables should you use them. Yeah. So the person on the top of the mountain is not fall there. So are you going to climb with me? Definitely yes.